بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 into their 8th online lesson. And in this lesson, we will continue with explaining the binomial theorem. So in the previous class, we have seen the binomial expansion. We have seen this formula which we use to expand any binomial. And we have seen the general term formula. So we saw that the general term formula was the following: T r plus 1 is equal to C n r times a to the power of n minus r times b to the power of r. We call this the general term formula, and the only relation that we usually use to solve the ministry questions. We have also seen the ratio of two consecutive terms, which is tr plus 1 over tr is equal to n minus r plus 1 over r multiplied by b over a, and we mean with b the second term and a the first term. Now we have seen these two formulas in the previous class, and I think we have emphasized that these are the main two formulas that we use in this lesson. This is the only rule that we use, and we use only this one whenever a ratio is mentioned. We have also seen some important notes, and we will start this lesson today by revising some of the important notes that we have talked about. And to revise them, we will do some exercises. So let's see. These are simple exercises. Number 1. Let's say that they want the number of terms in the expansion of 3x plus 7y to the power of 20 is dash. So the question is, how many terms do we have? How many terms do we have in 3x plus 7y to the power of 20? And the answer is quite easy. So to answer this one, always remember that it is the power plus 1. The number of terms is the power plus 1. So the power here is 20. So it's 20 plus 1, and the answer is 21. So that's the answer. Okay, another question. Let's see here. The sum of coefficients in the expansion of 2x minus y to the power of 5 is dash. Let's make it 15, spice it a little bit up. So, sum coefficients. How do we find the sum of coefficients? This was quite easy. We take the coefficient of the first term, which is 2, plus we take the coefficient of the second term, which is -1, and we raise it to the same power of the binomial, which is 15. So 2 plus minus 1 is 1, and 1 to the power of 15 is equal to 1. Okay, let's see a third one. For example, number 3. Let's say that if the number of terms in the expansion of um, 2x plus y to the power of 2n plus 4 is 21, then n equals dash. This question is like question 1, but in a reversed manner. We don't want to know the number of terms. We have the number of terms. The number of terms is 21. We want to know the power. So we know that the number of terms equals the power plus 1. In our case, the number of terms is 21. So that's equal to the power. The power is 2n plus 4 plus 1. Okay, so we can solve this equation now for n. We want to find n. So 21 minus 4 minus 1 equals 2n. I have transposed 4 and 1 to the other side. 21 minus 4 minus 1 is 16. So 16 is equal to 2n. We divide by 2 both sides. So n is equal to 8. So here n is equal to 8. Okay. Let's continue with some other examples. Number 4. The order of the middle term, the order of middle term or terms, because sometimes they can be two. So the order of middle term or terms in the expansion of 3x minus 7 to the power of 14 is or are dash. So if we have an even power, from the previous class we said if we have an even power, then we have one middle term only. And how do we find the order of that middle term? It will be t. We take the power divided by 2 and then add 1. So it's going to be t, the power is 14, divided by 2 plus 1. 14 divided by 2 is 7, plus 1 is 8, so this is t8. So the order is 8. They're asking about the order, so the order is 8. Or you can write t8, no problem. So this is the order of the middle term. Let's see. Let's write another question. For example, number 5. The sum of powers of each term in the expansion of x plus y to the power of 7 is dash. Okay, this is quite an easy question. The sum of powers in any expansion that looks like this is the same as the power here. So the sum of power in each term is always going to be the same as the power here, which is going to be 7. So the sum of powers is 7 as well. Okay. Let's see another question. Number 6. If the coefficient of T7 equals the coefficient of T15 in the expansion of x plus y to the power of n, then n equals dash. Now this one is a smart question. Look, now we have x plus y to the power of n. We don't know the power, but we know that the coefficient of t7 is the same as coefficient of t15. Okay guys, look at this. We know that the coefficients are symmetrical. This is what we said in the last lecture. The meaning of symmetrical, it means that a power from the right is going to be equal to the power from the left. So if 7 equals 15, this means that 6 equals 16 and 5 equals 17, because the powers from the left and from the right should be equal. We've seen this in the previous class. So if we carry on, 4, 3, 2, 1, we will carry on here with 4 terms, which are 18, 19, 20, and 21. So the first term will be equal to the 21st term. The second is to the 20th, and the third to the 19th, the fourth to the 18th, the fifth to the 17th, the sixth to the 16th, and the 7th to the 15th. As they said here, the 7th to the 15th. And since they are symmetrical, so as long as this is the first term, this will be our last term. This is going to be our last term. And if our last term is t21, it means we have 21 terms. And we know that the number of terms is equal to the power plus 1. So our power is n. So here 21 equals n plus 1, which means that n is simply how much? It will be 20. So the power should be 20. Okay, so what did we use to solve this question? We used the fact that the coefficients of the terms are symmetrical. Symmetrical means that they're the same from the left and from the right. So 7 is equal to 15, which means that 6 is equal to 16, 5 to 17. I've kept counting until I reached to the first term from the left, which was the same as the last term from the right. So if the last term is 21, it means we have 21 terms. And if we have 21 terms, the number of terms is always more than the power by 1. So if we have 21 terms, it means the power is simply 20. What if this question was a little bit different? What if this was not n? What if this was 2n? In this case, n will be how much? N will be 10. Because 20 divided by 2 is 10. The power is 2n, the power is 20, and n is 20 divided by 2, which is 10. Hope these are clear so far. See another one. Okay, another example. We can ask like the sum of coefficients in the expansion of x minus y to the power of n equals dash. Okay, so if we're talking about the sum of the coefficients, then we must mean the coefficient of the first term plus the coefficient of the second term to the power of n. The coefficient of the first term is 1 plus the coefficient of the second term is minus 1 to the power of n. This is going to be 0 to the power of n. And 0 to the power of n, anything is 0. So the answer here is 0. This was question number 7. All of these are typical ministry questions. Usually ministry questions, indirect ministry questions are like this. Okay, I might ask you the following. Look, so number 8. If the middle term in the expansion of 2x minus 7y to the power of 3n plus 1 is t. Let's see that. So we need okay, just t6, then n is equal to what? Okay, so in this question they gave us the middle term. The middle term is t6, so the order of the middle term is 6. And how many middle term do we have? We have one middle term. So if we have one middle term, we must know that this is going to be even. And if it is even, we know that the order of the middle term is t power divided by 2 plus 1 is t6. This is the middle term. Our power, let's ignore the t's. Let's look at the order, the subscript. Our power is 3n plus 1 divided by 2 plus 1 is equal to 6. Solve this for n. So transpose. So 3n plus 1 over 2 equals 5 because it's 6 minus 1. Cross multiply. 3n plus 1 equals 10. Transpose the 1. 3n is equal to 9. Divide by 3. So n is equal to 3. So the value of n here is 3. Good? I hope it's good. If you don't get any point, please go back to the previous lecture. Look at the rules that we have talked about, the notes that we have talked about, and we can repeat the question more than once. If you still don't get the answer, you can always ask me in my WhatsApp or in our group. You're welcome to ask anytime. Okay. Let's solve some direct questions now. Okay, let's see. So again, the formulas that we will use always are the general term tr plus 1 equals cnr a to the power of n minus r b to the power of r. And the second one is tr plus 1 over tr equals n minus r plus 1 over r times b over a. So these are usually the two rules that we use in most of the questions that we will see. So let's see some questions. We will start with some ministry questions, previous ministry questions regarding the binomial theorem. Okay, so now we'll start with some examples and then some previous ministry questions. So for example, exercises. Number 1, the question says find T5 in the expansion of um, 2x minus 4 over y squared all to the power of 10. Okay, so let's solve this question together. Here, look at this, guys. Now they want us to find the fifth term in the expansion of 2x minus 4 over y squared to the power of 10. Now if we expand this, we will actually find 11 terms. We will find 11 terms. They are from T1, T2, T3, going all the way up to T11. Now they don't want the whole expansion. This is what we did in the previous class. We did the whole expansion, but we did not do power 10, of course. We did smaller powers. but we did the whole expansion. They don't want the whole expansion. They want T5 somewhere here, before the middle, because the middle is T6 and T7. So it's before the middle. So I'm sorry, the middle one is T6 only. So before the middle, they want the term before the middle. How do we find that exact term? Okay, if we can still recall from the previous class, here the combination here was N0, and the combination here was N1, and the combination here was N2, and I mean with N10. So it is 10-0, and here 10-1, and here 10-2. And we kept going on with these combinations until we got to the combination of 10-10. I want you to notice something about R and the number of the term. You see the number of term is 1, the first term. R will be 0. If we are talking about the second term, R will be 1. If we are talking about the third term, R will be 2. You can even look this back in the previous lecture. The number of the term is always more than R by 1. This is why this rule is TR plus 1. Because it's telling you that the order of the term is always more than R by 1. So if they want T5, the order of the term is 5. So as long as the fifth term, then this means that R is equal to 4, because the term is more than the R by 1. So if it's the fifth term, then it means that this is R is equal to 4. If R is equal to 4, we can simply use this formula easily. Now, so therefore, T R plus 1 equals combination N R multiplied by A means the first term. So the first term is 2x to the power of N minus R times B. B is the second term with its sign. So minus 4 over y squared to the power of R, which is 4. So this is going to be T5. If we solve this one now in front of us, we will simply find the value of T5. So let's do that. So T5 equals 10 combination 4 is 10 permutation 4. 10 permutation 4 over 4 factorial times 10 minus 4 is 6. So it is 2 to the power of 6 times x to the power of 6 times negative 4 to the power of 4, negative 4 to the power of 4, and I will take this y up, so it becomes y to the power of minus 2, and I will also give it a power 4. Now this is going to be our common practice in a lot of questions, so you need to pay close attention to the following. Look at this, guys. I want you always to remember the following. If you have a times b to the power of m, like here, 2x to the power of 6, then what you do is you give the power m to a and you give the power m to b as well. So it's a to the power of m and b to the power of m. And if you have a over b, x to the power of m, then what I advise you to do is to give the power m to a, give the power m to b, but this x, take it up to the numerator, give it a power of minus 1 for sure, and then give it power m. My point is, if there is a number in the denominator, keep it. But if there is a variable in the denominator, like x or y, whatever, take it to the numerator and change the sign of its power, and then give it the same external power. So this x has a power of 1. I will take it to the numerator. It becomes x to the power of minus 1, and then I give it the power of m. Together, I will multiply them. So it will be a to the power of m over b to the power of m times x to the power of minus m. So this is basically what I did here. And please always do this in binomials. Always do these two in binomials. Distribute, this is going to be a key step in every question. Distribute, so 2 to the power of 6, x to the power of 6, this is what I did here. And in the second one, I distributed minus 4 to the power of 4, and this y squared, I took it to the numerator and I gave it the same power, 4. Now what do? T5 equals 10 permutation 4 numbers starting with 10, so 10 times 9 times 8 times 7 over 4 factorial, which is 4 times 3 times 2, times 2 to the power of 6 times x to the power of 6 times. When you give a negative to the power of 4, it becomes positive because a negative to an even power is positive. And you have 4 to the power of 4. You can write this 4 as 2 squared. So 2 squared to the power of 4. Instead of 4, 2 squared. Why? Because I will add these powers together. It's the same base. Times y to the power of minus 8. Multiplying these two powers together. Now we cancel what is possible. So I can cancel 4 with 2 with 8. I can cancel 3 with 9. I will get 3. 7 times 3 is 21. 21 times 10 is 210. So T5 equals 210. This here is 2 to the power of 8 because you'll multiply the powers. 2 times 4 is 8. So 2 to the power of 8. And this here is 2 to the power of 6. And they are multiplied. And in multiplication, we add the powers. So 2 to the power of 6 times 2 to the power of 8. We add the powers. It's going to be 6 plus 8, which is 2 to the power of 14. So this is times 2 to the power of 14, x to the power of 6, y to the power of minus 8. This is going to be the fifth term. And this is what they want in this question. Maybe we can simplify further if we calculate 2 to the power of 14 and then multiply it by 210, but usually this is not what you need to do. Just leave it like that. This is a good answer. Let's do another one. Okay, so let's see. Okay, this question says the following. The question says, find the seventh term. Question 2. Find the seventh term in the expansion of 2x minus y to the power of 2x minus y to the power of 9. Okay. This should be an easy question. Since we've solved the first one, now we know how to solve them. So let's see. What do they want? They want the seventh term. If what we want is the seventh term, then this means that r is equal to 6. Always remember that the term is more than r by 1. So if the term is 7, the r is 6, because the term is more than r by 1. So that's r. So we have only one rule. Remember always, we have only one rule we deal with. T r plus 1 equals c n r a to the power of n minus r b to the power of r. That's the rule that we deal with all the time. So how much is r in our case? R is 6. So we say t 6 plus 1, which is eventually will be 7, equals combination. N is the power, so the power is 9. R is 6 times a to the power, a is the first term, so let's erase it. A is the first term, so what is our first term? A is 2x, so we open a bracket, we write 2x to the power of 9 minus 6 times the second term is minus y to the power of 6. Okay, so combination 6, 9, 6. Combination 9, 6, according to the reduction formula, is the same as 9, and here 9 minus 6. So it is 9 and 3. So combination 9, 6 is actually 9 permutation 3 over 3 factorial, because it's the same as combination 9, 3, times 2, 9 minus 6 is 3, and x to the power of 3. You have to separate the number from the variable, so you give each one of them the power, times minus 1 to the power of 6 times y to the power of 6. Separate the number from the variable. So we did that. Now 9 permutation 3 is 9 times 8 times 7 over 3 factorial is 3 times 2 times 2 cubed times x cubed times negative 1 to the even power is positive, so times y to the power of 6. Cancel 3 with 9, we get 3. 2 with 8, we get 4. 3 times 4 is 12. And 12 times 7 is 84. So this is 84 times 2 cubed, which is 8, times x cubed times y to the power of 6. I think this can be evaluated easily. So 84 times 8. So 8 times 80 is 640, and 8 times 4 is 32. So the answer is 672 x cubed y to the power of 6. And this is going to be the 7th term. So the 7th term is equal to 672 x cubed y to the power of 6. Okay? I hope this question is also clear. And let's check a new idea now. Okay, so here, question number 3. Was that number 2? Yes, number 3. Okay, this question says the following. It says, find the middle term of the expansion of, or in the expansion of 2x squared minus 1 over 2x all to the power of 12. So they want us to find the middle term of this one. And it's different when they ask about finding the middle term and finding the order of the middle term. When they ask about the order of the middle term, they just want the number of the term. Which term it is. Is it T1? Is it T7? Is it T6? Is it T8? Whatever. So when they ask about the order, they just want the number of the term. But when they ask about the middle term itself, it means that they want you to evaluate it. They want you to calculate it and tell me how much it is, the whole term. So, first of all, before we find the middle term, we need to know which term it is. What is the order of it? And since the power is even, we will have only one middle term. So the power is even, right? And if the power is even, it means we have one middle term. And the order of this middle term is going to be t power divided by 2 plus 1. So it's going to be t, the power is 12, divided by 2 plus 1. So it's going to be t, 12 divided by 2 is 6, 6 plus 1 is 7. So it's going to be t7. So what we want is the 7th term. And if we want is the 7th term, if what we want is the 7th term, then r is equal to 6. Good? Because the term is always more than r by 1. And if r is 6, we can use the general formula. So tr plus 1 equals combination n r a to the power of n minus r, b to the power of r. Which means t, r in our case is 6, so 6 plus 1. This is going to be t7, which is the middle term, equals combination n is 12 and r is 6 times a is the first term, which is 2x squared to the power of 12 minus 6 n minus r times b. b is negative 1 over 2x to the power of r alone, which is 6. This is n minus r, this is r alone. Good. Now what do we do next? We have to split the numbers from the variables. So what do we do this? How do we do this? We say t7 equals 12 combination 6 is actually 12 permutation 6 over 6 factorial and cannot be reduced. It will be the same answer if we reduce it. Times 2 to the power of 6 is alone. And x squared to the power of 6 is alone. So you separate them. Then minus half to the power of 6 is alone. And x to the power of minus 1 to the power of 6 is alone. Now notice, guys, that we have removed the x from the denominator to the numerator and we changed the power. So the power has become minus 1 and we gave it then the same external power, which is 6. And minus half is separated from x. I hope this is clear so far. So let's continue. So T7 equals 12 permutation 6 is 12 times 11 times 10 times 9 times 8 times 7 over, that's 6 actions for sure, 6 times 5 times 4 times 3 times 2 times 2 to the power of 6 times x to the power of 12 times, if there is a negative and the power is even, then we leave it. It's positive, it becomes positive. So you'll have 1 to the power of 6 in the numerator over 2 to the power of 6 in the denominator times x, you multiply these two powers by each other, minus 1 times 6 is minus 6. Okay. Now comes the cancelling. So let's cancel what we can. Let's change the pen. Okay, so let's see. What we can cancel is the following. I can cancel for sure 6 with 12, I will get 2. I can cancel 5 with 10, I will get 2. I can cancel 3 with 9, I will get 3. I can cancel 2 with 8, I will get 4. I can cancel then 2 to the power of 6 with 2 to the power of 6. 1 to the power of 6 is 1, so this does not matter. When we multiply these two, since they have the same base, we will add the powers. So 12 plus minus 6 is 6. So let's see what do we get. So here, T7, which is the middle term, equals 2 times 11, which is 22, times 2, which is 44. 44 times 3, which is 132. And 132 times 4 is 528. And times 7. I'll just use a calculator for that. So 528 times 7. Let's see. Of course, in the exam, you'll have plenty of time to calculate this. So you do calculate it. If it's in the choices, you have to calculate it. Times 4 and 528, as we said, times 7. So this is 3,696. We've cancelled these two together, so we only have x to the power of 6. So this is going to be our T7. or this is the middle term. So the middle term in this expansion, the middle term in this expansion is this. This is the middle term. If we open it again, this is going to be 13 terms, right? 13 terms. So مثلا this is T1, T2, T3, T10, T11, T11, T12, T13, 13 terms. The middle one here is going to be T7, and what is the value of T7? It is right here. This is the value of T7. Okay, so this is my final answer. I hope this one is also clear. Let's investigate another question. Let's see this one. Okay, so this is question 4. Find the ratio of the two middle terms in the expansion of 3x minus 2y to the power of 11. Okay, so here they're asking us to find the ratio of the two middle terms. For sure, if they're asking about ratio, then this is the second formula, which is TR plus 1 over TR. So we will use TR plus 1 over TR equals N minus R plus 1 over R times B over A. That's certain. The first problem that we have is that we know that they want the middle terms, the two middle terms, but we don't know what is the order of these two middle terms. Which terms they are. Are they the first term and the second term? Are these the middle terms? Or maybe they are the 7th term and the 8th term. Or maybe they are the 6th term and the 5th term. We just don't know. So before we start solving this question, before we start using this formula in front of you, we will have to know which terms they are. Which terms are the middle terms? And to do this, we have to look at the power. The power is odd. So if the power is odd, the first one is going to be the power, t power, plus 1 first to make it even, and then we divide by 2. This is how we find the first one of the middle terms. So it's going to be t, 11 plus 1 over 2. 11 plus 1 is 12, so it's going to be 12 over 2, which is t6. So the first term is t6, and the second term is going to be the next one, which is t7. So they want the ratio of the two middle terms. They want the ratio of t6 and t7. So here we can write this. The middle terms are t6 and t7. Good. So these are the middle terms. Okay, now we want to find the ratio. Since we have the terms now, we can put this ratio. What do we put on top? Of course, we put the bigger one because it's r plus 1. We put the bigger one. So we put t7 here on top over t6. So t7 over t6 equals n. N means the power. The power is 11. Minus r is the smaller one here. Which one is the smaller one? It is 6. Plus 1 over r, which is 6, times b. B means the second term. The second term is negative 2y over a, the first term, which is 3x. So this is the ratio of the two terms. We simplify this and we find the answer. Now, a common mistake for a lot of students here is that they say 6 plus 1 is 7, and then they say 11 minus 7. 11 minus 7 is 4. That's not right. That's wrong. Why? Because this is not 6. This is minus 6. Minus 6 plus 1 is minus 5. 11 minus 5 is 6. So again, let's do this. So T7 over T6 equals. You can say 11 minus 6 is 5. 5 plus 1 is 6. So this is 6 over 6 times negative 2y over 3x. Cancel 6 with 6. So T7 over T6 is equal to negative 2 over 3 y over x. And this is going to be the ratio of the two middle terms. So if we expand this, we will get 12 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? The middle ones are going to be the 6th one and the 7th one. These are the middle ones. If we divide the 7th one, T7, by the 6th one, T6, the final answer after cancelling is going to be negative 2 over 3 y over x. This is the ratio of the two middle terms, the one we have just found here. Okay, hope you understand this question well, and I hope that you're getting into the mode of binomial, because the questions of binomial are all like this. They're questions of calculation, but they're good questions. Let's continue. Let's do another question. So question 5. Find the ratio of the coefficients of T8 to T9 in the expansion of let's say okay, a squared plus 3 over a to the power of 12. Okay guys, so let's understand the question first. So guys, look at this. The power is 13, right? I'm sorry, the power is 12, right? And if the power is 12, it means we have 13 terms. So T1, T2, T3, T4, 5, 6, 7, T8, T9, T10, T11, T12, T13. 13 terms. Now we don't care about all of these terms. We care about T8 and T9. Each term, as we have seen before, is usually composed of a coefficient and an x or y, or a in our case. For example, T8 will be something like, for example, 81a cubed, or whatever. This is called the coefficient, and this is the variable. So they want the ratio of the coefficients. They don't want the variable. They just want the coefficients of T8 and the coefficient of T9. If we divide them over each other, how much do we get? And how do we do that? Okay, it's the same as what we did earlier. We use this formula, TR plus 1 over TR. Look, it's only two formulas. You don't invent anything. Just do the formulas that you have. N minus R over 1 plus R over R times B over A. Just do the formula. Okay. In the top one should be the bigger one, which is T9. So T9 over T8. However, guys, look at this. They want T8 over T9. What they want is T8 over T9. What are we doing now? We are doing T9 over T8. Yes, because the rule says that the bigger one should be on top and the smaller one in the bottom. So it's okay. We'll do this now, and when we get the final answer, we will flip it to get T8 over T9, because this is what we want, T8 over T9. Good? So we'll just continue with T9 over T8. T9 over T8 equals n is the power 12 minus r is the smaller one, which is 8, plus 1 over r, which is 8, times b. b is 3 over a. And you know that I don't like fractions over fractions. So this is b, divide a. And a is what? It's a squared. I did this because I don't like fractions over fractions. So T9 over T8 equals 12 minus 8 is 4. 4 plus 1 is 5. So that's 5 over 8. Multiplied by, keep, change, and flip. Now, what I strongly recommend you here is you do what I did in the previous question, which is write the numbers first and then write the letters. So it's T9 over T8 equals 5 times 3 is 15 over 8 times 1 over a cubed. A times a squared is a cubed. Separate the number from the variables. Okay, guys. Now, what do they want? They don't want the variables. They want the coefficients. So what are you going to take? You're going to take this. And they don't want T9 over T8. They want T8 over T9. So what are you going to do to this fraction? You will flip it. So therefore, the ratio of coefficients of T8 to T9 is what? It's going to be T8 to T9, huh? T8 over T9. So 8 over 15 is going to be 8 to 15. And what about the variable? We will just ignore the variable. So this variable now is ignored. Why? Because they only ask about the coefficients. And that's the final answer. I hope this one is also clear. And now let's investigate a new type of questions. Okay, let's see. Question number 6. Okay, this question says the following. It says find the coefficient of x to the power of 10 in the expansion of 2x minus 3 to the power of 14. Okay, so let's see how do we solve this question. Now let's try to understand this question first before we attempt to solve it. Now look at this, guys. The power here is 14. The power is clearly 14. And if the power is 14, it means we have 15 terms. 15 terms. Now in these terms, we'll have x's, like x cubed, x to the power of 14, x to the power of 13, x to the power of 12. We will have a lot of x's. The question is, we want to find the coefficient of x to the power of 10. The important question now is, where is x to the power of 10? In which term it is? Is it in the 5th term? Maybe it's in the 7th term. Maybe in the 6th term. We just don't know. Maybe it's in the last term. So we don't know where is x to the power of 10. right? So how do we do it? Do we expand the whole thing and look for x to the power of 10? No, we don't. What we do is only using one rule only. That's the only rule we have. If it is not ratio, then it's this rule. T r plus 1 equals combination n r a to the power of n minus r times b to the power of r. Now look at this, guys. We know how much is n. How much is n? N is 14, but we just don't know how much is r. We don't know which term it is, so we don't know how much is r. So what do we do? What do? I just continue normally. I don't have any other way. So T r plus 1 equals combination 14 and r. How much is r? I just don't know. Times a. A is I know. It's 2x to the power of n minus r, right? But we know n. N is how much? N is 14. So instead of n, we write 14. So 14 minus r times b. B is what? B is negative 3 to the power of r. Okay, what do we do next? What I do usually, which is separating the letters or the variables from the coefficients. So 14r times 2 to the power of 14 minus r times x to the power of 14 minus r times negative 3 to the power of r. Good? Now, I can't do anything more than this because I just don't know how much is r. However, I know that the x I am looking for has a power of 10. The x I have has a power of 14 minus r. So why don't we put 14 minus r equals to 10. Why? Because this power, I want it to become 10. I want it to be 10. I want 14 minus r to be 10. This is what I want to solve. If I do this, then I can find the value of r by transposing minus r to this side to become positive and transposing the 10 to the other side. So I'll have 14 minus 10 is equal to r. 14 minus 10 is 4, and 4 is equal to r. So we found r. If we find r, we can substitute here. So this is t4 plus 1, which is t5, equals combination 14 and 4. 2 to the power of 14 minus 4. X to the power of 14 minus 4, and negative 3 to the power of 4. Okay, so we found everything. Now we can find the term and then find the coefficient. So this is T5 equals 14 permutation, 14 combination 4 is 14 permutation 4, 4 actions, 14 times 13 times 12 times 11 over 4 factorial, which is 4 times 3 times 2 times 2 to the power of 10 times x to the power of 10 times a negative to an even power is positive, so 3 to the power of 4. Let's cancel what we can. So we can cancel what? We can cancel 4 with 12 and 3 as well. So 4 and 3 with 12, we have nothing left. And 2 with 14, we get 7. So we're left with 7. 7 times 13 times 11. 7 times 11 is 77. And 77 times 13. So T5 equals 77 times 13. We can solve here. So 10 times 77 is 770, and 3 times 77 is 231. So the answer is going to be 1 and 0 1 here and 10. So it is 1001 multiplied by 2 to the power of 10 multiplied by 3 to the power of 4 times x to the power of 10. And since we want the coefficient only, since the question is asking about the coefficient only, then the coefficient is going to be this one, this part. So we can say eventually that the coefficient of T5 is equal to 1001 times 2 to the power of 10 times 3 to the power of 4. Okay, so let's see a new question. This is question number 7. Okay, this question has a similar idea to the previous question and says the following. It says find the free term of x, the free term of x in the expansion of of 2x to the power of 5 minus 1 over x to the power of 3, and all of that is to the power of 8. Okay, so this question says find the free term of x in the expansion of 2x to the power of 5 minus 1 over x cubed to the power of 8. And here have an important expression, free term of x. Look at this, guys. This is power 8, so when we open it, we expect 9 terms, right? Now one of these terms is going to be a pure number without an x. This is the free term of x. The free term of x is the term that does not have x. And why would the term be empty of x? Why wouldn't we have x? Simply because x will have a power of 0. If x has a power of 0, it's free term of x. It's not going to appear, right? So we are looking for a term in which x will have a power of 0. But which term is this? We don't know. Which means how much is r? We don't know. So this is similar to the previous question, but in the previous question we were looking for x to the power of 10, right? In this question we will be looking for x to the power of 0. So we will be looking for the free term of x. So how do we do it? We have only one rule. Let's do it. So tr plus 1 equals combination n r a to the power of n minus r and b to the power of r. So we don't know which term it is, and that's why this is still tr plus 1 equals combination n, the power we know, it's 8, r we don't know. A is the first term, which is 2x to the power of 5, and then we give it a power of n minus r, 8 minus r, times b. B is negative 1 over x cubed, and we give it a power of r. So this is to the power of r. What do we do next? We do an important step, which is splitting the coefficients from the variables. This is a very important step. We have to split the numbers from the variables. So let's do it. So we get here tr plus 1 equals combination 8r 2 to the power of 8 minus r times x to the power of 5 to the power of 8 minus r times negative 1 to the power of r times x to the power of minus 3 to the power of r. Always remember to take x to the numerator. It's a variable, we have to take it to the numerator. It's a number, we keep it in this place. Now you see here x has 2 powers and here x has 2 powers. Let's multiply these 2 powers. So t r plus 1 equals combination 8r 2 to the power of 8 minus r minus 1 to the power of r. I'm putting the numbers at the beginning. And x to the power of 40 minus 5r. Because we multiply 5 by 8, we get 40, 5 by r, 5r. And we multiply minus 3 by r, minus 3r. And since they're both x, the base is x, let's put the powers together, minus 3r. So let's collect all the powers together. So we have one base, which is x, which is the same for both the two x's before. So one base, x, and the power is 40 minus 5r from the first x, and negative 3r from the second x. We just collect them together because it's the same base. Now, I want this long power, I want to put this long power, which is 40 minus 8r basically, because it's minus 5r and minus 3r. I want it to be how much? I want it to be 0. So if I want it to become 0, this means that 40 is equal to 8r, cancel by 8 both sides. So r is equal to 40 over 8, and that is going to be equals to 5. So we found r. If we have found r, we will come back here. We will say t 5 plus 1 equals combination 8, 5 times 2 to the power of 8 minus 5 times minus 1 to the power of 5 times x to the power of 40 minus 5 times 5, which is 25, minus 3 times 5, which is 15. Is this good so far? I hope it is. Let's continue here. So, the term that we are looking for is going to be T6. 5 plus 1 equals combination 8, 5 is the same as combination 8, 5 is the same as combination 8 and 8 minus 5, which is combination 8, 3, which is 8 permutation 3 over 3 factorial, right? So combination 8, 5 is going to be 8 times 7 times 6, which is 8 permutation 3 over 3 factorial, 3 times 2, times 2 to the power of 8 minus 5, which is 2 to the power of 3, times, and negative has an odd power, so it becomes negative. Don't write it here, write it at the beginning of the term. So here, minus. So minus 1 to the power of 5 is minus. It's at the beginning of the term. The term is negative. Times x to the power of 40 minus 25 is 15. 15 minus 15 is x to the power of 0. Let's cancel what we can. We can cancel 3, 2 with 6. So we will get T6 equals minus 8 times 7 times 8. 8, this one, times 7 times 8, which is 2 cubed, times 1, which is x to the power of 0. So this term is indeed free of x. We don't have x. So we will multiply minus 8 times 7 times 8. Minus 8 times 7 is going to be 56. And 56 times 8 is going to be 448. So this is minus 448. So this is now T6, the sixth term. So this is the first, the second, the third, the fourth, the fifth, the sixth. This term here is going to be free of x, and it's going to have, the value of the term is going to be minus 448 only. In the other terms, we will have x's, x to the power of whatever. But in this term, the sixth term, we will not have an x. It's going to be free of x, and the value of that term is minus 448. Okay? So this is a question in which we have to find the free term of x. Let's continue. Let's add some more questions. Okay, let's see. Question number 8. Okay. Let's look at a new idea. So okay, here this question says the following. Given that T13 equals T14 in the expansion of 1 minus x to the power of 25. The question is, find the value of x. Find the value of x. Okay. So which x do they want? They want the value of x right here, this x. How much is it? Okay. This question actually has two ways to answer it. First of all, let's change the pen. So first of all, do we know how much is T13? We don't. Do we know how much is T14? We also don't. So we can start by finding each one of them. That's one way to solve this question. And to be honest with you, this is the harder way. So let's start with it. So how do we find T13? T13 means that R is equal to 12, right? So let's do it. T13 equals combination 25 and here what? 12. Combination 25, 12 times A, which is 1 to the power of 25 minus 12 times B minus X to the power of R, which is 12. Okay, attempting to open this one is craziness. To open 25 combination 12, you must be crazy. So don't open it. 25, 12, it means 12 actions starting with 25 over 12 factorial. This is too much to work. So just leave it closed like that. So do not evaluate it. Say T13 equals combination 25, 12 times 1 to the power of whatever is 1 times minus x to the power of 12. If there is a minus and has an even power, it becomes plus. So you only have x to the power of 12. So it's equal to combination 25, 12 and x to the power of 12. Okay, so you can say that this is T13. Using the same manner, find T14. So T14. If it's T14, then R is how much? R is 13. So T14 equals combination N and R. R is 13, huh? Times A to the power of N minus R times B, which is minus X, to the power of R. Let's simplify that. So T14 equals, again, do not attempt to solve this one, but you can reduce it because 13 is more than half of 25. Half of 25 is 12.5. 13 is more, so reduce it. So it's going to be 25 minus 13, which is 12. So this is combination 25 and 12 times 1 to the power of Jinni is 1. So 1 is as it is, times And negative to the power of odd is going to be negative. I must have, okay, so negative, and x to the power of 13 is x to the power of 13. Now what do you do? Now, because T13 equals T14, okay, because they're equal to each other, therefore, T13 is this one, so therefore combination 25, 12, x to the power of 12 equals minus this one, I mean, which is minus combination 25, 12, x to the power of 13. Now what can we do? We'll do something here, which is this combination and this combination that we have been avoiding to expand is the same, so we can cancel it from both sides. Divide by it. Divide by combination 25, 12, we cancel from both sides. So what do we get now? We will get x to the power of 12 equals minus x to the power of 13. Let's transpose them into one side. So x to the power of 12 plus x to the power of 13 is equal to 0. Take x to the power of 12 as a common factor. So what do we still have? We still have 1 plus x equals 0. Either x to the power of 12 equals to 0, or 1 plus x equals to 0. So either x is equal to 0, and in this case this answer is rejected, and we will see now in a while why is it rejected, or x is equal to, move this here, so x is equal to minus 1. Now we usually reject the 0 because the question should have been find the non-zero value of x. The non-zero value of x. The question was supposed to be like this, so it's the non-zero value of x, so we don't take the 0. We take x is equal to minus 1. So this is one way to do it. We found the value of x. And to be honest with you, this was the complicated way. This certain question has another way, another method, which is easier than this one. Another method. What is it? I will start from the beginning. I know that T14 equals T13. It's the same thing, right? T13 equals T14 or the opposite. What do I do? Now, I am going to divide both of them by T13, both sides. So divide here by T13, divide here by T13. So T14 over T13 equals T13 over T13, which means that T14 over T13 equals to 1. Is that good? Hope it is. Now look at this, guys. This is the ratio of two consecutive terms. Ratio of two consecutive terms. So we use the formula, which is n minus r plus 1 over r times b over a. It will be equal to 1. So this one is a formula. Let's substitute the formula. The formula is 25 minus r. R is the smaller one, and the smaller one is 13, plus 1 over 13 times b. B is minus x over a. A is 1 equals to 1. Good? What do we do next? 25 minus 13 is 12. 12 plus 1 is 13. 13 over 13 is 1. So this is 1. All of this is 1. And minus x over 1 is minus x. So minus x equals 1. Multiply by negative 1 both sides. So x is equal to negative 1. And that is the answer. So we got the same answer, but using a shorter way. And actually, this way does not work all the time, to be honest with you. It worked in this question because I have noticed that these two are consecutive. They're 13 and 14. If they were not consecutive, we were going to solve it using the first method only. So this method worked because these two were consecutive. Okay, hope this is clear. I know this class has got a little bit longer than usual, but we're drawing to an end. So let's see. Let's add some more examples. Question number 9. Okay, let's see this question. The question says the following. In the expansion of 1 plus x to the power of n, 1 plus x to the power of n, in the expansion of 1 plus x to the power of n, if the coefficients of the 8th and the 9th term are equal to each other, the question is, and if T7 over T5 equals 44 over 75. So the question is, find the value or values of x and n, of n comma x. Okay, this might be our last question for this class, so let's pay close attention to it. In the expansion of 1 plus x to the power of n, so we don't know the power, and eventually they will ask us also to find x. If the coefficients of the 8th and 9th term are equal to each other, so coefficient of T8 equals coefficient of T9. Are these after each other? Yes, they are. If they are after each other, I am going to divide by T8, the smaller one, both of them. So we can say that T9 over T8, coefficient of course, coefficient of T9 over coefficient of T8 equals coefficient of T8 over coefficient of T8. I am dividing by the coefficient of T8. So if we divide by the coefficient of T8, both of them, we get something like this. Coefficient of T8 cancels coefficient of T8, we get 1 in this side equals coefficient of T9 over coefficient of T8 is n minus r plus 1 over r times b over a, and we will take the coefficient of this. So let's do it. N we don't know. Minus r is the smaller one, which is 8. Plus 1 over r is 8. Times b is the second term, which is x, over a, which is 1, equals to 1. Now look at this, guys. We don't care about x because we want the coefficients only. So we will just remove this x. We'll just take the coefficient. So n minus 8 plus 1 is minus 7 over 8 is equal to, we have just removed that. We don't care about the variable, we care about the coefficients. because from here they want the coefficients only, equals to 1. I can cross multiply now here. So if we cross multiply, we will get n minus 7 equals to 8. I can move minus 7 to the side, so n equals 8 plus 7, and n is equal to 15. I found the value of n now. So finding the value of n, now we will attempt to find the value of x. How? We will use this piece of information. T7 over T5 equals 44 over 75. How do we find x from it? Now they are not after each other, right? They're not after each other because T7 and T5. So we can't use the ratio. So what do we do? Okay, there are actually two ways to do it. I can find T7. Find how much is it using this formula, which is combination n6 times a to the power of n minus 6 and b to the power of 6. And because I have n now, n is 15, I can substitute 15. And 6 because this is 7. And I can find T5, which is combination n4, a to the power of n minus 4 and b to the power of 4. And then I will divide them by each other and make it equal to 44 over 7 and then find x. I encourage you to try this method. Please try it. Please try it and tell me what you get. I will actually solve it using another method that I think is smarter, and I want you to be exposed to it. I want you to see it because it might be useful for you someday. You see, I want T7 over T5. I told you before a while that we cannot use the formula of the ratio. Or maybe we can. How? The ratio works only if these are after each other. So T7, T5, they're not after each other, they're not consecutive. There is T6 missing. T6 is missing, right? It's between them. However, why don't I write T7 over T5 as T7 over T6 times T6 over T5? Isn't this and this equal? Look, T6 cancels T6, you get T7 over T5. They're equal. But what have I done now? I have made two consecutive terms here and two consecutive terms here. So I can use the formula here and I can use the formula again here. I can use the formula 2 times. How? Let's see. Look, T7 over T5, I know how much is it. How much is T7 over T5? It is 44 over 75 equals T7 over T6 is n, right? N, which is how much? We've just found it, 15, minus r, the smaller one, 6, plus 1 over r times b over a. b is x and a is 1. And he's not saying the coefficients here. He said T7 over T6, over T7 over T5. Not the coefficients, so I'm not going to ignore the x, I'm going to keep it. Times, the other one is T6 over T5, it's also the same rule, which is n, minus the smaller r, which is 5, plus 1 over the smaller r, times b over a. Good? Now what do we do? Simplify. 44 over 75 equals 15 minus 6 is 9. 9 plus 1 is 10. So this is 10 over 6 times, let's do the other fraction. 15 minus 5 is 10. 10 plus 1 is 11. So this is 11 over 5 times x over 1 times x over 1 is simply x squared over 1. Now we can cancel from both sides. I actually can cancel the following. I can cancel 11 by 11, I get 1, and 44 by 11, I get 4. Okay. I can cancel 5 by 5, I get 1. I can cancel 75 by 5, I will get 15. Good. Are we done? Not yet. I can cancel 10 by 2 with 6. So by 2 I get 5, and here by 2 I get 3. I can cancel 3 with 15. By 3 I get 1. By 3 I get 5. Can I cancel this 5 with this 5? Don't you dare do that. Because this is in the denominator and this is in the numerator. And there is an equal between them. You can't. So what do? You write what's left. 4 over 5. 4 over 5 equals, here what do we have? We have 5x squared. What do we want to make the subject? We want x to be the subject. So I'll divide by 5. I don't like to divide and there is a fraction. So I'm going to multiply by 1 over 5. Both sides. To cancel the 5. So what are we going to get? We will get 4 over 25 equals x squared. I'll take the root for both sides. So x is going to be equals to plus minus 2 over 5. So these are the values, the possible values of x. And here we had the possible values of n. I hope that this is clear. I know that this class was a little bit heavy, but you have all the time at home. You can just pause the video whenever you're tired. You can repeat whatever you don't understand. And with this example, we will be done with chapter 2 completely. This is everything that we had to learn in chapter 2. We learned the counting principle, permutations, combination, and eventually the binomial theorem. Soon, inshallah, I'm going to give you a revision for chapter 2, some questions, multiple choice questions, and I encourage you to solve these questions and send them back to me. And inshallah, next week I am going to start with chapter 3. I might be releasing a video every day next week, so we finish before the end of Ramadan, inshallah. We still have chapter 3 and chapter 4, but these are the shortest chapters. So you don't worry about those. I don't think that they will take us much. Maybe they will take us 6 videos, I guess, maybe 6 or 7 at most. And we will be done with them, and we will be done with the whole curriculum, inshallah. So I hope that you have a nice week, nice weekend. I'm not going to see you until next week. Please study hard. Take the advantage of these days that you're staying at home. Study hard. The more you study, the better you're prepared for your future. Eventually, this is going to pass, and we will be free to go outside again. And at that time, some of you are going to be prepared very well, and some of you will just have wasted their time in non-important stuff. So what I encourage you to do is try to prepare yourself. This is a chance for you. You have plenty of free time. Study hard, and I'm sure that you'll have great futures, inshallah. So until next time, stay safe, stay home, and see you inshallah next time.